Alright. Good evening, teachers and whoever else this may concern. I am Raghav Sriram from 4G, and today I'll be explaining the code for my physics GA. I'm representing my team, who consist of me, Veniko, Ryan An, and Aaron Gore. Okay, so I will be going through two different codes today, based on what we have prepared for our project. Firstly, the automatic mode, where it's supposed to work autonomously, and then the manual control mode. So in the automatic mode, firstly, the robot starts up and we initialize the smart camera. We also take our servo arm and we make it upright. Then we wait for two things. Firstly, a button to be pressed on a Bluetooth controller. This is supposed to act like communication between a control tower and the actual robot itself, signifying that a ship is about to dock. And then when the robot senses a ship with ultrasonic sensor distance, it will then wait 6 seconds and move forward to board the ship after it is docked. Then, depending on whether it senses cargo aboard the ship with, again, ultrasonic distance, it will either unload or load cargo. If it senses cargo on the ship, it will unload it. If it does not, it will load cargo onto it. So firstly, for the unloading sequence. Over here, if it senses cargo on the ship, it will move forward until the cargo is within the reach or the grasp of the robot. Then it will move down its servo to lock it into place and move backwards until the line follower at the bottom of the robot senses the back strip of tape. At this point, it will then turn for a bit and then line follow such that the robot is able to place the cargo at the edge, after which it will lift up the servo arm and then move backwards, which then restores its position. And on the other hand, if it wants to load cargo onto a ship, essentially what it will do is that it will move backwards until the line follower detects all white, and then turn and essentially move forward until the line follower detects all white again. This is to recalibrate its movement. And then afterwards, it will essentially line track until it reaches a cargo at the bottom strip. This will essentially, this robot will essentially then close it into its grasp using the servo and then detect the color of it. If it matches the wrong color, which is red in this case, then what will happen is that it will unlatch the servo arm and move backwards and switch side by going to the other end of the white strip. And then it'll line track until it senses the other container, lock it, and then bring that container onto the ship. That can be done, as you can see, by the line follower detects all white and the other movement scripts that you have over here. Essentially, this will just turn it backwards, turn it, and move it forward until it senses the middle strip, in which it will move forward and recalibrate itself to go perpendicular to the back strip, and then it will go to the ship, unlatch, and move backwards so that it deposits it there. And in the event that the first color is actually the correct color, which is in this case blue, it will again commence the act of closing down the servo, moving backwards, turning to the right, moving forwards, recalibrating using the middle strip line following, and then after that it will line follow forward, move forward, open the servo, and essentially move backwards, effectively depositing the cargo there. The line tracker algorithm is pretty simple. Looking at the line follower, if it has the right side black and the left side white, it will turn left. If it has the left side black and the right side white, it will turn right for a very small amount of time with a very low power, because this is supposed to be precise rather than fast. And the line follower, if it detects all white, it will move forward. This is a simple line tracker algorithm that I have created. And then after that, we have our other code, which is the manual override. In this manual override, it is very simple. Everything is in a forever loop, which is why we had to make it a separate code. We cannot inculcate it as part of this other code. And essentially what should happen is that the controller, if the L1 or R1 buttons are pressed, which are the index finger holder buttons, then it can control the servo arm going up and down to lock and unlock. Then if button 1 is pressed, based on the ultrasonic sensor, it can give either an output of a color blue or red, which can tell pilots who are piloting it from afar whether the robot is within range of something. And then the main idea of how it works in movement is this algorithm over here, where the left wheel turns at a power of the left joystick's y plus the left joystick's x values, while the right wheel turns at the power of the left joystick's y minus the left joystick's x values. This allows it such that if you move the joystick to the sides, it will spin. However, if you move it forward or forward and slightly to the side, it will act as if a car does. This makes it effective for precise movement in a very crowded environment with a lot of cargo around. The good thing about this line tracker algorithm is that this can work in many other places that do not follow a similar orientation to this, which have white tape though. And that is generally speaking what we have for our presentation. Thank you. And Nilsen elaborate.